Alright, so we do a review today for test 3. So the section covered will be 8.1, 8.2, 8.3, 8.4, 8.5, 8.6. Okay, that's for test 3. Well, those sections are kind of easier, reality, so there's no need to drop anything here. Okay, those sections they are comparable, easy. Okay. All right. So first two sections are about sequences, and those last four sections are about series. Okay. All right. So why don't we start with 8.1, 8.2, so on. Okay. So the best way to do probably is to look at the exercise, the homework problem that I assigned to you. Okay. So first of all, so let's review 8.1 first. Anyone have any question or you want me to do it in 8.1? Anyone? Okay, well, then if it, yeah, okay, yeah.
Can you do the recurring, is that the recurring?
Recurring, okay. Yeah, that's right. Recurring, okay, good question, okay. Recurring is, good question, that's right. So it's it's more on the it's like 17 and so on, like problem 17. 17 and so on. Okay? So anyway, let's do some problems out of this. Okay? So how about just pick up one problem? So how about let's do 19. Okay, 19 is this recurrence, right? So it says write the first four terms. Write the first four terms. Okay, of the sequence. AN defined by the following relation, okay, by the following recurrence relation. All right, so number 19 says A sub n plus 1 equal to 3a sub n minus 12. And they give you a1 is 10. Alright, so they want us to write the first four terms, right? So okay, so the first term is a1 is you don't have to do anything, you just copy a1. First term, okay? Now second term is what? Is a sub 2, right? Now how do you get a sub 2? Well, then I have to use this relation. A sub 2, right? 2 is what? Is when this n equal to 1. Right? So 1 because 1 plus 1 is 2. So if this is 1, okay, if this is 1, okay, 1 plus 1 is 2. So that means this is 3a1 minus 12. Okay, because 1 plus 1 is 2, right? So a2 equals 3. Now, what's n? N is 1. Okay, this is the case where n equals to 1. So, a2 is 3a1 minus 12. What is a1? We know 10. 30 is 80. Okay? Now, how about a sub 3? Well, a sub 3, right? Well, n plus 1, what? 3, that means this is 2. This number is 2. 2. Okay. So this is 3a times 2 minus 4. So 3 times a sub 2 is what? 18 minus 12. 54 minus 12. 42. Okay, and then a sub 4, because they want 4 terms. 1, 2, 3, 4. The first term we don't have to do anything. but the other three have to do something. So A sub 4 is when this is 4, right? So that means when A equals to 3, that's A4. Okay? So A sub 4 is when A equals to 3, so this equals to 3, A sub 3 minus 12. So this is 3 times, now what is A sub 3? 12, right? Times 42. So this is 140. So this is the second term, third term, fourth term. Okay? Any question? Any question about this? Any question you want to see along this line? This is what problem I said, 9 to 37, right? Limit of sequence, right? Okay, so okay, so why don't we do maybe one more here? Do you have any question first of all? All this looks simple.
Can you do 33?
33. Okay, let's do 33. A sub n. Let me put this down here, man. 114003, right? This is today is what? 4, 5. Alright. So 33. So it is what? A sub n equals 1 over 10 to the n. And n can be anything. N start with 1. Okay. And what they want, okay, write the first 4 terms. Okay, so there are several things they want to ask you. Write the first 4 terms. Okay, so what? So the first term is when n equal to 1, right? The second term is when n equal to 2. The third term is when n equal to 3. The fourth term is when n equal to 4, which is 1 over 10 to the 4. Okay, so those are the first 4 terms. But I think that's not the only question they have. If the sequence appears to converge, make a conjecture about the limit. If the sequence diverges, explain it. For the A sub n, this is 1 over 10 to the n. So the larger the n is, the bigger, of course, the bigger the 10 to the n is, but 1 over 10 to the n makes to be very small. So as n goes to infinity, A sub n, which is 1 over 10 to the n, goes to 0. So therefore, the sequence. So therefore, the sequence converges to 0. Any question about this 8.1? Okay, well, let's go to 8.2 because we have 6 sections to cover. So, and again, feel free to ask questions. Okay. All right. So we are looking at 8.2. Any question about these sections 8.2?
31.
31. 31, okay. N sine 6 over n. Now what do they want? Let's see. They want find the limit of the following sequences or determine that the limit does not exist. Okay? So the question is, we have to find this. So first of all, does this exist? And then if it exists, what is it? Okay? Alright, well, when n goes to infinity, this goes to 1. Okay, so as n goes to infinity, 6 over n goes to 0. Sine 0 is 0. But n goes to infinity, so I have, if I just look at this expression, this is infinity times 0. Okay. When n goes to infinity, well, that's infinity. Sine 6 over n, well, when n goes to infinity, 6 over infinity is 0. Sine 0 is 0. So you have this form. This form in mathematics is called indeterminate form. Okay, I'm sure you have learned it in calculus 1. This kind of form is indeterminate. Indeterminate form in calculus 1, and this is a perfect setting for L'Hopital's rule. Okay, so how do I use L'Hopital's rule? I'm going to just try to set it up the ratio of something such that each one of them will go to 0 or go to infinity. So I'm very easy, just bring the n to the denominator. This equals this. Now, then when n goes to infinity, 1 over n goes to 0. So this 0 over 0. This is 0 over 0 case. This one. So it's a natural setting for L'Hopital's rule. Okay? So I'm going to use L'Hopital's rule. So this is equal to limit differentiate sine 6 over n divided by 1 over n, and the derivative of 1 over n. Derivative of sine, right? Here, remember, I have to use chain rule. So I have cosine of 6 over n, and then we differentiate this. So then I'm going to differentiate this, so it's 6 times minus 1 over n squared. Same as this, derivative of 1 over n is negative 1 over n squared. Okay. So I'm going to cancel the n squared, like a limit, n goes to infinity. I'm going to cancel this. Oh, in fact, I'm going to cancel negative 1 over n squared. So I have 6 times cosine 6 over n. And this, of course, is equal to 6 times limit and go to infinity. Cosine of 6 over n. Cosine, when n goes to infinity, 6 over n goes to 0. Cosine 0 is 1. This is 1. 1 times 6, 6. Okay, so the answer is yes, this sequence, so therefore the answer is what? Answer is this sequence converges to 6.